Welcome. Today we are going to start the new topic, probability and statistics in mathematics. So let us discuss some of the contents that we are going to cover. We will be focusing on 5 things. The first is then we will come to talk about types of events. You will understand how many types of events are there. Then we will understand about how do we approach to probability. Then we will understand some of the axioms of probability, and at last we will learn some rules regarding the probability. There will be 6 rules that we will be discussing, and this will cover whole of your GATE syllabus for probability. So today our primary focus will be over probability, and in the next lecture we will study about statistics. Alright, let's start. The first topic is probability fundamentals. We will understand that what are the various parts or terms used in probability. The first term that we use is sample space, which is a very important part. Now let us understand what is the sample space. So you can say that this is set of a set of all possible outcomes of an experiment. All possible outcomes. For example, if you just roll a dice, then you will either get 1, 2, 3, 4, 5 or 6. It's a standard dice. So you can't get more than 6 digits in a dice when you toss it or roll it. So these are the possible outcomes. These are the only possible outcomes. So for a dice, the sample space for space will be 1, 2, 3, 4, 5 and 6. I think this should be clear. Second term that we use is event. Now we will understand what is an event. First of all, it is denoted by, you can say, E. It is a subset of a sample space. Now what does this mean? Let us take the same example of rolling a dice. You already knew the sample space, the possible outcomes were 1 to 6. Now if I say that you have to toss it and say you get only even numbers, say. So what are you doing here? You are only focusing over 2, 4 and 6 out of all these 6. So it is a part of this set, or also known as a subset. So such subset from a sample set, following some rule or condition, is known as event. Now we will understand about some terms such as this is event E, this is event F, E, F, it's alone E, say this one is E and this one is F. So when I talk about union, it is shown by the sign union F. So when I talk about union, it means all the elements coming in event E as well as event F. So the shaded portion over here represents E union F. When I talk about intersection, this means all the parts that are common between E and F, that's known as intersection. It is shown like E intersection F. So we are focusing over the shaded portion. Since this part is E, now if I talk about complementary, that is, you have to find the complement of E event, that is everything except the E. It covers everything except the E. This is the complementary, and in this we can write, see over here, E is a subset of F. So I can say that E subset of, it belongs to F, it comes inside the F. Our next topic of today's discussion is types of events. This is our second topic. Now we will understand what are the events, what are the types of, we understood what are events, but now we will try to understand what are the types of events. So there are 5 types of event. The first type is complementary event. So if we talk about any event E, then its complementary will be something that consists of other things except that are present in E event. So this is the first type, that's a complementary event. So the example will be like you threw the dice. If I talk that event should be even, if I say this, then 2, 4 and 6 will be the event. So the complementary of this event will be all that is remaining, that is nothing but odd event. The other type of event is equally likely event. So in this we are comparing two events, so let's say E and F. Now E and F will be said to be equally likely events if and only if probability of happening of E is exactly equals to probability of happening of event F. For example, over here the same thing. If we are rolling a dice, then the probability of getting an even event is even event is 1 to 3 and the sample space is 6, so it will becomes 3 upon 6 1 by 2. Similarly, the probability of odd events will be again 3 by 6. So here both probability of both events are equal, so they are example of equally likely. The other type of event is mutually exclusive. Now two events E and F are some events and they will be mutually exclusive if E occurs and F cannot occurs, and if F occurs then E cannot occurs. That means both of them both of them cannot occur both of them cannot occur together. That's what's the meaning of mutual exclusive events. The another type is collectively exhaustive. What is this? Say we take again E and F, two events. Now these two events will be collectively exhaustive if probability of E union with F is equals to. That means these two when combined together they contains all possible outcomes. Another type of event is independent event. So again, if we take two events E and F, so the two events E and F are independent if and only if probability of intersection of E and F will be equal to probability of E plus probability of F. This is the first thing. And what does this mean? This is the conditional probability. This is a conditional probability. What does this mean? It means that probability of event E when F is completed. So since these both events are independent of each other, so it doesn't matter if F is completed or not. It will not affect the probability of E. Therefore, this will be equivalent to probability of E. Similarly, we can say that the probability of event F when E is completed is equals to probability of event F. So these were the types of events. Let's move further. Our next topic is approaches to probability. In this we will understand how do we calculate probability. So there are two ways. The first way is classical approach. In this approach we use a very common principle or a formula, that is if we want to find probability of any event then it is equals to number of ways an event can happen divided by number of ways in sample space. So if we take an example of a coin, it has two faces, one is head, one is tails. So if I want to know the probability of getting head, then it will be equal to number of ways an event can happen. Head can occur one time. Number of ways in a sample space, there are two ways a coin can turn out. One is heads, another is tails, so it will be 2. The probability will be. So this is a classical approach. Another is a frequency based approach to probability. Let us understand this using an example. This is the following question. From the following table, find the probability of obtaining A grade. Now we need to find probability of obtaining A grade. So by using a frequency approach, what we will do, we will first find the total number of students, that is 100. Then by frequency approach, probability of getting an A grade will be equal to number of students in A grade divided by total students. Number of students in grade A is 10, so we will write here 10. Total number of students is 100. So from here we will get. So this was an example of frequency approach to probability. Next topic is axioms of probability. So there are two axioms. The first one is, if there is a probability of any event, say there is an event E and we need to find its probability, then its value will be lying between 0 to 1. It will lie somewhere between 0 to 1. So we can write it as probability of any event will be in between 1, 0, 0 and 1. This is an axiom 1. Second axiom is the probability of a sample space will always be equal to 1. That's it. These are the two axioms of probability.